Have you ever noticed how the world around us is constantly in motion? From the gentle sway of trees in the breeze to the rapid flight of a bird, we are surrounded by objects that are changing their positions continuously. This change in position of an object with respect to time is what we call motion. Think about a car driving down the road. As the car moves from one point to another, its position relative to its starting point changes. This change in position over time is the essence of motion. We can observe motion in countless everyday examples, such as a ball rolling across the floor, a child swinging on a swing, or even the earth revolving around the sun. Understanding motion is fundamental to comprehending the physical world around us. It allows us to describe and predict the movement of objects, from the smallest particles to the largest celestial bodies. By studying motion, we gain insights into the forces that govern the universe and the fundamental laws that dictate how objects interact. Motion is not always straightforward. It can take on various forms depending on how an object's speed and direction change over time. Let's explore two fundamental types of motion: uniform motion and non-uniform motion. Uniform motion describes the movement of an object at a constant speed in a straight line. Imagine a car traveling on a highway at a steady speed of 60 kilometers per hour without changing its direction. This car is exhibiting uniform motion because its speed and direction remain constant. Other examples of uniform motion include a train moving at a constant velocity on a straight track, or an airplane cruising at a fixed altitude and speed. Now, let's contrast uniform motion with non-uniform motion. Non-uniform motion occurs when an object's speed or direction, or both, change over time. Think of a car navigating a winding road. Its speed and direction constantly adjust as it maneuvers through curves and hills. This dynamic movement exemplifies non-uniform motion. Other examples include a ball thrown vertically upwards, a pendulum swinging back and forth, or a roller coaster navigating its twists and turns. When discussing motion, it's crucial to distinguish between two important concepts: distance and displacement. While they may seem similar at first glance, they represent distinct aspects of an object's movement. Distance refers to the total length of the path covered by an object during its motion. Imagine you walk from your home to school, taking a winding path through a park. The distance you cover is the total length of the path you walked, regardless of the direction you took. Distance is a scalar quantity, meaning it only has magnitude and no direction. Displacement, on the other hand, represents the overall change in the position of an object from its initial point to its final point. It is the shortest distance between the starting and ending points, regardless of the path taken. In our previous example, your displacement would be the straight line distance between your home and school, irrespective of the winding path you took through the park. Displacement is a vector quantity, meaning it has both magnitude and direction. Speed and velocity are two fundamental concepts in physics that describe how fast an object is moving. While they are often used interchangeably in everyday language, they have distinct meanings in physics. Speed refers to how fast an object is moving, regardless of its direction. It tells us the rate at which an object covers distance. For instance, if a car travels 100 kilometers in 2 hours, its speed is 50 kilometers per hour. Speed is a scalar quantity, meaning it only has magnitude and no direction. Velocity, on the other hand, combines speed with direction. It tells us not only how fast an object is moving, but also in what direction it is moving. For example, if a car is traveling north at 60 kilometers per hour, its velocity is 60 kilometers per hour north. Velocity is a vector quantity, meaning it has both magnitude, which is speed, and direction.